Okay, so we are going to start working on Isobar Activity 2, and a couple of things before we get started. Remember that we can have air pressure in two different types of units when we're talking about weather. You can see it in the measurement in millibars. So for example, this would be a recording of the air pressure in millibars, or you could see it in inches of mercury. For our weather project, and most meteorologists are going to use millibars. And so when we're doing our data dig next week, if you don't have it listed on the website like this, that we're getting our data from, then I'll give you a converter calculator to where you can convert the inches of mercury to millibars. So when we're doing our data dig, don't take time to do that conversion. Wait until you have all your data for the day done. Okay, so we are going to be working in millibars. One thing to remember that we've already talked about is that on a weather map, they are going to have changed the way that they write the numbers on the map. And that's because if we look over here at the raw data from a map, you can see that there's a decimal point, there's a whole bunch of numbers, and when I look at that, all I see is numbers and dots. And so one way to kind of clarify or clean up the map is they've come up with a standard way of kind of abbreviating or formatting the number when we write it on the weather map. And the standard way to do a format is that you're going to take, let's say for example, we'll take this 1019.2. You get rid of the decimal. When we do our weather map, we're going to use dots to represent rain. So slight rain, moderate rain, heavy rain. And so we don't want those decimal points to be confused with the precipitation symbol. So we get rid of the decimal, and then you're going to write down the 3 digits. So if you look over on this side on the format, you can see that they've written down 192. Now, if we look here at 1001, you have to assume, even if you just had this as your data, you have to assume that there's a decimal point there. And so you get rid of the decimal and you write the digits. You have to write 3 numbers. Why? It's standard, and you don't want it to be confused with any of the other measurements that we're going to put on the map. So a meteorologist looking at a formatted weather map would know that we are writing down the air pressure in a 3 number system. Another thing to keep in mind is that, well, what if it's under 1,000? What do we do if it's under 1,000? And so that's going to be a little different. You're going to write the 3 numbers and don't worry about the decimal. Oh, sorry, I made a mistake. They do take off the decimal. So let me back up here. So 999.5, you take off the decimal, and you're going to write down 995. Now, when you're doing your isobars, someone just looking at this who has not been in class would say, well, 980 is way higher pressure than 028. And that would be someone who hasn't had any training and didn't understand that this was formatted for a weather map. But a meteorologist would look at this and they would understand that 980 is a lower pressure than the 1028 because they would know how these 2 numbers came about. Okay, so again, we format the numbers, kind of making it simpler to where there's not as many digits and there's not that decimal point there. It just makes the map a little cleaner to look at, and that's going to make way more sense to you when we start putting on our data, all of our data. Okay, so for this activity, we're going to shade numbers in a range. when you do isobars on the project, you're not going to color anything for pressure. The only color that's going to be on your weather map is going to be for temperature. We're using color here to help us figure out where the isobars are going to fall. Okay, so we're going to start out, and you can see that the ones that fall in the range from 960 to 999 have been shaded in dark. So if we looked at the map, we can see there is a low pressure area right there. Okay, now let's go look at the next one. The next isobar up, so this would be for drawing the isobar 1000. That would help us with 1000. And so this one is going to help us with 1000 and drawing the isobar 1004. Remember that isobars go in increments of 4. Isotherms go in increments of 10 for our purpose. We could do it in 1s, we could do it in 0.5s, we could do it in 0.2s. It just depends on how sensitive you want your weather data to be. We're going to do isobars by 4 because that's usually what you're going to see when you're watching the Weather Channel or watching the weather forecast on your local news station. Okay, so on this part, we have shaded everything that's going to be in the range between 1000 and 39. So this would be 1039.0. So we're going to be coloring a shade, all of the air pressure that's going to fall between the isobar 1000 and 1004. Okay, these are not the isobars. The dots and the colors are only helping us find where we're going to draw our line. Okay, the next one. Here we're coloring a range. And this next isobar is going to be 1008. If we go to the next one. So the colors really are insignificant. They're just trying to help us find where we're going to be drawing our isobar. We could do different shades of gray. We could do different shades of pink. We don't have to color at all. We're only doing the color, remember, to help us see where to draw the ice lines. Okay, so now we can kind of see some separation areas. So, we can see where the purples are, we can see where the blues are. So now it's time to start putting in our iso lines. And so let's start with our iso line for 1000. So our iso line that we're drawing is going to be the isobar 1000. Remember that when your isobar comes in and out of the map, you have to label it. And if it's in the middle of the map, you also have to label it. That tells your reader what that measurement is. So once we have our lines on here, if we got rid of all the dots and all the numbers and left just our circles, we would be able to tell what was going on with the air pressure. Okay, so you can start anywhere. And so if I look over here, there are no values anywhere close to 0, 0, 0, because this would be this in the formatted form. So I'm not going to start over there. So I'm going to start over here on the other side. And I see 980 and I see 001. So 1000 is going to fit somewhere between 1001.3 and the air pressure of 980. So I know that my 000 is going to fit in between here. Okay. So our next iso line that we're going to draw so we just did that one, sorry, is going to be the ISO line for 1004. And on the map, on the map, that's going to be written as 0, 4, 0. So when we draw our ISO line, we are going to be estimating where the measurement of 40 is going to fall. So where is the air pressure 1004? So if I had 40 here, 38 here, 50 here, 37. So I'm going to start here because that's exactly on, sorry, I need to put zeros here. Sorry, thinking too fast. That's exactly where my isobar I'm going to draw. So I can connect these two because they're the same. And then I got to ask myself, which direction am I going to go next? And so I can't draw my isobar between these two because 040 doesn't fit through there. I can draw my isobar through these two because the line does fit through there. For some reason, there we go. So 40 fits between these. So I have to estimate where would 40 fit there. Is it going to be closer to the 50, closer to the 37? Now, if you want to be really accurate, you would divide the space in half, figure out how many degrees between them would be, and then delineate it down. But as a general, just eyeballing it, I know that 40 is going to be closer to 37 than it is going to be to 50. So that's going to be the start there of my 1004 isobar. Okay, so again, we can go, where's our colored one? I don't know. Oh, I guess I didn't do colors here. So we're going to draw 1004. Doesn't matter where you start. Over here, I don't see any 40s. Over here on the right, I don't see any 40s in the middle. I don't see anything under 40. And then I get over here, and I'm starting to see some numbers close to 040, which is 1004 for our isobar. And so if I start here at the 36, and I look at the 36 and the 81, again, it doesn't matter where I start. I'm going to estimate, is 040 closer to 81 or closer to 36? So I'm going to put a dot where I think that 040 would fall. And I'm going to do this lightly in pencil. And then I'm going to decide, well, which direction am I going to go next? And so does 40 fit between 81 and 113? Well, the answer is no. So again, I'm doing this lightly in pencil. So I can't go that direction. Does it fit between 113 and 79? No, I can't go there. Does it fit between 79 and 13? And the answer is yes. So it does fall between here. And I'm going to estimate about there. Okay, so here we have 77 and 980. And you might think, well, no, 40 doesn't fit there. But remember, this is under 1,000. So 40, the isobar of 1004 would fit there. And so I'm going to say it's going to be somewhere over here. And then will it fit between under 1,000 and 28? Yes. No, because 40 is higher than the air pressure of 1,000, 2.8. So I can't go there. Okay, 28 and 77. 40 fits in between there. I'm going to say it's closer to 28. Again, doing this lightly in pencil. Does it fit between 77 and 112? No, I can't go there. 112 and 113? No, I can't go there. 112 and 74? No, I can't go there. Oh, 28 and 74. Yes, I can go through there. So I'm going to estimate my dot there. Okay, and so I've got a pretty good start here. So now let's look up at the top and see where we can go. Here we have 81 and 5. And so 040 will fit between there. Here we have 100 and 135. No, I can't go there. 135 and 81. No, I can't go there. But 40 does fit between 05 and 100. So I'm going to start my ISO line for 1040. So if we erased everything on this map, the dots, my pencil marks, the numbers, and just left the ISO line I just drew, my reader would understand that everywhere on this line is the air pressure of 1004. Okay, so if we keep on going, it fits between here and between here. And then between here. Remember, we had our 1,000 here. So that's good, I think, for 1004. And so we'll leave it there for now, and maybe we'll have to come back and do some edits, but we'll leave it right there. Okay, now let's look at 1008. And remember that this is going to be written as 080 on the map in the formatted form. And so everywhere that I draw my line, I'm telling my reader that the air pressure is 1008. Okay, so let's see. I'm going to start anywhere. Over here, I don't see anything close to 80. I don't see anything close to 80 here. If I look here, oh, there's an 81 right there. So that's a good place to start. So if I look here, I can't put my dot there because 80 doesn't fall between 81 and 13. But I know that that is a good place to start because 81 is very close to my isobar I want to draw. Okay. So let's see, I got to find a place where 80 is between. So 180, 80 is not going to be between there. 135 and 80 not going to be there. 155 not there. Here we already talked about. Let's see, 136. Well, 80 fits between there. And so 80 is going to be closer to the 100. And again, I'm doing this in pencil very lightly. So that's going to be my first spot. So 136, then I look at 105. It's going to be closer to the 100. It can't go between 118 and 135. I can't go there. Can't go between 100 and 135. Can't go here. But can it go between 36 and 81? Yes. And it's going to be very close to the 80, 81. Then I got 36 and 113. Okay, 36 and 79. It can't go here because 080 doesn't fall in between there. So then I got to look again. Okay, here I have 79 and 113. Well, 80 would fit there, and it'd be very close to the 79. Okay, 113 and 116. 40 can't go there. It doesn't fall between 113 and 161. Sorry, not 116. And here's 130 on the dot, 140 on the dot. But the problem lies in that, can I go across here? That's got to be my question. And if I look at here, I have a 77 and a 161. And yes, 80 does fall between there. So I can go in between them. Okay, so now I have my iso line. And I always start these off in pencil before I go back with a Sharpie or a black marker to put in my iso lines. That in case I make a mistake or need to back up. Okay, so now I need to decide where I need to go from here. It won't go between these two. It can't go between these two. 112 and 59. It can't go between those two. 77 and 112. Well, 080 will fall between there, and it'll be closer to the 77. 28 and 74. It can't go here because 80 doesn't fall between there, so I can't go there. I can't go here. It doesn't fall between 28 and 77. So I've got my dot going here. I'm trying to figure out which direction I'm going to go next. Here I have 74 and 112. Well, it can go through there. It's going to be closer to the 74. Okay, 74 and 113. 89. 80. So I get to here, and in 68 and 42, I can't go through there, so I got to back up a little bit. And go here. Remember, when your line leaves the map, you have to label it, and when it enters the map, you have to label it. Okay? That's 1008. I guess I should change this. Okay, so we're not a computer. We're estimating with our eyeballs. So that when the computer drew it, of course, it's going to look prettier than ours. Okay. Now let's do 1012. Look at all these typos. Oh my goodness. So this would be 120 on the map when we're drawing our isobar for 1012. So again, it doesn't matter where you start. Do I see any 120s over here? No. Anything close to 120 here? No. Anything close to 120 here? Well, yeah, 116 is kind of close. So I'm going to start by looking at this dot here at 116. And I'm trying to find a place where the 120 would fit. So it's not going to fit between 189 and 113. Will it fit between 89 and 116? No. Will it fit between 116 and 87? No. Will it fit between 116 and 146? Yes. And it's going to be closer to that 116. So I'm looking for values of 120. Okay. So 146 and 141. 120 can't go through there, so I can't go there. 141 and 140, I can't go there. 87 and 141, I can go there. And so it's going to be closer to the 147. So I got 2 lines there. I have my 87 and my 140. We don't have any data for what's going on past here, so it's just going to leave our map. Okay, so let's start estimating a little quicker. So closer to 113, closer to 113 instead of 185, closer to 112 instead of 159. I can't go to between 140 and 159, kind of in the middle. Kind of closer to 79 to 161, 113 and 75, closer to 113, 81 and 146, kind of in the middle, 135, 155, I can't go there because 120 doesn't fit in between there. So if I look over to the left, I can go between 81 and 135, 100 and 135, I can go between 118 and 135, it's going to be closer to the 118. And then I don't have any data for past my map. Well, I don't know why it's not drawing there. There we go. Again, when I leave the map, I got to label my isobar. Now, there could be a 1012 on the other side of the map. So when you are drawing isobars, they can occur in different locations. Just keep that in mind, that it's not one isobar per map. So that's our 1012 millibars. Okay, so let's go on to the next one. Again, the computer is going to draw it much more precise than we are when we're estimating. Okay, let's go to 116. And remember that this is going to be written as 160 on the map. Again, it doesn't matter where you start. You can start anywhere. And so if I go over here, I really don't see anything close to 160, so that's not a good place to start. I look here, there's not anything really close to 160 there, so that's not a good place to start. Oh, 159 is pretty close to 160, so let me start there. So I'm going to look at 159, 189, and 160 is going to be closer to the 159. So now we have a starting point. Okay, so let's see where we're going to go. 159, kind of in the middle of 135 and 180. 160 goes between 135 and 160. And I'm going to write 160 up here so I'll remember, in pencil remember. I can kind of remember which one I'm doing. Because when I'm doing these, sometimes I fit, am I doing 120? Am I doing 140? What am I doing? And so if I put the number up there in pencil so I can erase it later, I know it reminds me of what I'm working on. So 143 and 166. My line is left. So I label my iso line. Okay, so now let's see where we go now. Let's see. 160. 160. I can't go between 112 and 159 to the left because 160 doesn't fit there. So I have to go this direction, closer to 159. Kind of in the middle, really close to 161. I can't go between 161 and 175 on the right because 160 doesn't fit in that number range. So I got to look for a different path, closer to the 175, kind of there, there. Okay, so my line's left the map, and so I'm going to label it. Oh, I thought I was going to label it. There we go. Okay. So that's our 1016. And again, later on in the map, we might find another spot. But for right now, we're going to be golden. And if we're going to go by fours, the next isobar we're going to look at would be, again, the computer's doing it much better than we are. We're going to do the millibars of 1020. Standard pressure at sea level is, goodness, is that 1013.25 millibars. If it's higher than this, then we're working on a high pressure system. If it's lower than this, then we're working on a low pressure system. So standard pressure at sea level. And remember that the height above sea level is elevation. Okay, so here we go. Oh, so on the map, we're going to be looking for numbers in where we're going to put the value for 200. Where is it going to fit on the map? So we scroll up. I'm going to write down that I'm going to be working on 200 in pencil up here very lightly. And let's see, I don't see anything close to 200 here. Nothing really close here. Kind of close here. But I see 180 and 210. And I know that 200 fits in between there. So I could start here. Or I could look and see if there are any exact 200s on the map. So I'm going to start here. Why not? Okay, so I know that 200 fits between 180 and 200. And so I'm going to estimate that it's going to fall about right here. 180 and 209. Okay, I can't go to the left because it's, oh wait, I got an exact 180. Why didn't, oh, we're doing 200. See, there you go. I was looking at 180. So, 200 is not going to fall between 180 and 197, so I can't go to the left, so I've got to keep on plugging. I know it's going to fit here, and it's be closer to 197, kind of in the middle. Oh, here's an exact 200, so I could have started there if I wanted to. Again, I'm leaving the map. So I'm going to label my iso line and then see if I can go anywhere else. Okay, so it fits here. Now, I can't go to the right. I can't go between 200 and 216 because 200 doesn't fit there. So I got to kind of reevaluate. Oh, 189 and 216, it fits in between there and here. I can't go any farther to the right because it doesn't fit in between 202 and 216. I'm going to estimate my way up, making sure that 200 falls where I'm placing it, and then it works through the number line. Sometimes I get to a spot, I'm like, oh, it doesn't go through, and I have to erase my line and go back to where I started. So that's okay. So just know that you should do this in pencil at first. Get your isobar where you want it to be, and then you can erase your pencil. You can put it in marker or a Sharpie and erase your pencil marks. Okay. So, okay, I can't go between 191 and 190 on the left because 200 doesn't fit there, but I can go this way. Okay, so I'm leaving my map. So I label my isobar. Okay, now I know the answer, so I'm just going to go ahead and show you that 200 does fall somewhere else on the map. And so even if we just kept going by, did 24 next and then kept on going, we would realize where the next 200 would be. And so if we look up here we have 210 and 84. And so 200 is going to work its way here. Okay, I can't go between 202 and 217 because it doesn't fit in between there. So I can't go straight down. And I can't go back to the left. So it does go between 179 and 253. It does not go between 210 and 245, so I can't go there. It doesn't go between 210 and 240, so I can't go there. So it has to go this way. Does it fit between 210 and 203? Yes. Can I go between 245 and 234? No. Did I make a wrong turn? Yes, I made a wrong turn. See, right here, 200 doesn't fit between 203 and 245. But I can go around the 203. And then I got to ask myself, will it whip back into the map? And the answer is no. And so here I have another isobar of the pressure of 1,020 millibars. Okay? And remember, if we erased all the numbers and all the weather station dots, and all we had was our lines on the map, our person viewing our map would know that everywhere on that line, the air pressure is 1,020. So if I lived right here, I would expect my air pressure to be 1,020. Again, the computer is going to estimate it way better than I can, or that you can, I hope, unless you're like super duper crazy estimator. I don't know. Okay, so the next one, if we go in increments, is going to be 1,024 millibars. This is going to be written on the map as 240. So if I look for where 240 would fall, there's nothing anywhere close to 240 over here. Nothing close to 240 over here. Again, I'm going to write this up here so I'll remember. There is some 249 up there, and that's, 202 and 249. 240 fits between there. So I can start there. Doesn't matter where you start. But it fits there, so I'm going to start there. And it's going to be closer to the 249. So then I got to ask myself, which direction am I going to go? And so it does fit between 231 and 240. I can't go between 249 and 245, so I can't go to the right. It does go between here does go between these two. And here's an exact 240. I can't go here because it doesn't fit between 217 and 179. So I'm not going to go right and up. 210 and 245, it will fit between there. But I have to make sure that when I draw this, that I'm not crossing any areas where it couldn't cross. So 253 and 179, it does fit between there, but sometimes it won't. And so you won't be able to go down. So you got to make sure that when you're crossing pressures, that your number still fits in between there. Okay, 234 and 271, yes, yes. Okay, 240, 240, closer to 243. It doesn't fit between 209 and 220, so I can't go left and down. It doesn't fit between 249 and 243, so I can't go up and to the right. What to do? What to do? Once you get how to do this, it's easy. It's just taking that time to have your brain sit and think about it. I know our brains don't like to think, and I know we just like to copy the answer and be done with it. So, but once you get this, you got it and you're golden. Okay? So there is our 1024. The line doesn't enter or leave the map. It's kind of enclosed on our map, but we still have to label it so that our reader, when it looks at that isobar, will know what that measurement is. And so now if we look at this, we got to ask ourselves, well, are we going to draw any more isobars? So we take a look. So we have a range between 1,000 to 1,024 millibars of pressure so far. And remember that we're going to go by fours. And so the next highest isobar would be 1,028. And so are there any values of 280 on the map? 271 gets close, but no. So we're probably pretty good with stopping for our isolines. Okay? Now some of you might be looking up here at this 200 all by itself. You could do this if you wanted to. That's the only information we have for that area right now. And then label it. Because we can't go through these numbers. So then we got to look here and look at, are there any high or low pressure systems? And what we're looking for is concentric circles. Just having, one spot that has high pressure, like if we were looking right here, we couldn't really say this area here was high or low pressure. So we're looking for concentric circles. And what concentric means is the lines are going around each other. Remember, the iso lines don't cross each other, and they kind of follow each other in a track out. Okay, so we do have a couple of spaces of that. And so we have this line, and it kind of goes around this line. And so we got to ask ourselves, is this a high or low pressure system? And so 257 is higher than 209. And so we have 24, we have 1,024, and then 20. And so as we're going out from the center, the air is getting lower, the air pressure. So this is a high pressure system because the highest pressure is on the inside. Okay? Over here we have some concentric circles or some lines that are around each other. And so we look at the pressure. We have 1,000, 1,004, and 1,008. So the pressure is going up as we leave. And so that means this is a low pressure system because the lowest pressure is on the inside. Don't forget your vocabulary words, a cyclone and anticyclone. And don't forget which way the winds are going to blow. They're going to blow from a high pressure to a lower pressure. And the cyclone and anticyclone are going to either blow clockwise or counterclockwise or in towards the systems or out towards the system. Winds also blow like in between 141 and 145. The wind, there might be a slight breeze in between this area here because that is a pressure difference, and wind is going to move as a mass from a high pressure to low pressure. So I hope that helped you figure out how to do isobars. And there you go.